Check, 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 check. Exchange is awesome. Everybody hates Yammer. Okay, good. I know the audio is working then. All right, good deal. Thank you. Well, great. Since we know everybody hates Yammer, and that was my best joke, I got to forewarn you. Let's go ahead and get started. For those of you I haven't met, I'm Paul Robichaux. I'm here to talk about Exchange Unified Messaging for the next hour or thereabouts. And I want to emphasize that Exchange UM is actually it's something I'm really enthusiastic about. It's a very cool piece of technology because I came up in a time when having a computer that you could just talk to recognize what you say was kind of science fiction-y. So let's see if I walk back this way, is it going to pull the projector over? No. Maybe I need to use my mime skills. Huh? All right. Yeah, exactly. That was the only demo you're getting. Actually, so let me start off by asking a couple of questions to get a little bit better understanding of what you guys are doing. How many of you have Exchange 2010 or 2013 UM already deployed? Okay, so most of you do. How many of you are thinking about deploying it in, say, the next 6 months? Okay. How many of you are using Office 365? All right, that's about what I expected. Normally when I do sessions like this, starting in about 2008, right? Microsoft first shipped UM as a feature in Exchange 2007. And starting in about 2008 until maybe 2012, the majority of people who would come to my UM sessions were people who were curious about the technology, wanted to know how it worked, wanted to know what they could do with it. And starting in 2011, 2012-ish, the balance started to tip, and I started seeing these sessions mostly filled with people who had already deployed UM and wanted to know more about how it worked and what it was for and what they could do with it. So I'm going to make the assumption that all of y'all are in that basket. So I'm not going to spend a lot of time talking about the fundamentals of UM or why you would use it. I want to instead spend time focusing on some of the things that you may not know, even after you have it deployed. Because one of the cool things about UM, but is also sort of one of the bad things about UM, is that it's mostly self-tuning and self-configuring. There are not a lot of knobs you can adjust to control its performance or its behavior. That's good because it makes it simple for us as administrators, but it's bad because it means we don't have as much control over the way the UM subsystem behaves as we do, say, over how the ESE works, for example. So just to briefly level set, do I actually have any reformed Lotus Notes administrators in here? Outstanding. Welcome back to the light side. I always like to ask that just to kind of give me a feel for where everybody's at. Who back earlier in their career administered Exchange 5.5? Outstanding. I'm here with my people. I love it. From a UM standpoint, what does Exchange do? It answers the phone. All right, that's the elevator pitch that I give people, particularly Lync administrators, because there are a lot of folks who are very familiar with Lync who still don't quite understand how Exchange UM and Lync go together. And there are a lot of people in the outside world who don't understand that Exchange UM means that you have something answering the phone, but that Exchange is not the phone. Right? It's not providing you telephony services. It's not making the phone ring. It doesn't do the things that a PBX or that Lync will do for you. So it'll answer the phone for one person, for a group of people, or for an automated attendant. It records voice messages. You all obviously already know that. A couple of different audio formats you can use, a whole bunch of things that it can do after it receives the voice message, some of which we're going to talk about. It can do a text-to-speech transcription. It can apply information rights management to make it harder, but not impossible, for the recipient to forward that voicemail. A couple other things that you're probably familiar with. Then it puts those voice messages in people's inbox folders. So when Microsoft first started talking about unified messaging, there were several other vendors who did and still do use that term. And it means different things according to which vendor you talk to. But in the Microsoft lexicon, unified messaging means two things. One is that your voicemail goes to the same place as all your other email. Now, I'm going to be really impressed if the clutter feature can work on my voicemail, because I've certainly got some people I'd like to put on the clutter list, right? That's machine learning that we can use. But the other thing that it lets you do is it gives you a telephone-based way to access all that data that's in your inbox. So when you think about it, right, the keynote this morning talked about the aggregate value of the data that's in your Exchange store and how machine learning can squeeze some of that value out in ways you might not expect to help individual users be more productive. Well, the team recognized that quite some time ago and said, hey, you know what, we've got all this valuable data in the inbox, let's give people new routes to get to it through what ended up being called Outlook Voice Access. Another thing that can do that a lot of people don't spend any time thinking about is that it can make outbound calls. Now, a minute ago, I said, oh, wait a minute, it's not a phone. But when it makes an outbound call, what's really happening is that it is sending a request to some other device on the network, asking it to place the call and then connecting to it to route audio. So when you think about what happens, for example, when you dial into Outlook Voice Access and place a dial by name call, or when you think about what happens when you use Play on Phone, both of those are cases where Exchange is going to ask another endpoint on the network to make a call on Exchange's behalf. But one thing I found in talking to administrators is there's still a lot of confusion about how that actually happens. And more to the point, what happens or doesn't happen when that doesn't work. So I want to spend some time talking about that too. So normally I would have had a spiffy whiteboard in here to draw on, and I don't. So what I'm going to do instead is walk through some textual descriptions. By the way, I'm just saying, in case there anybody from the MEC organizing team, the Link conference guys loved me enough to give me one of those 82-inch PPIs to draw on for my session, and I don't see one in here. I'm just saying. Then again, SharePoint got Bill Clinton to come talk, so I'm beginning to see where MEC ranks in terms of. We got Ross Smith talking. That's true, and personally, I don't mean to turn this into a political discussion, but I would rather watch that video with Greg and David Espinosa again than hear any former president talk. I don't care who you are. That was some comedy gold right there. So in 2010 and in 2007, is anybody still using Exchange 2007? Okay. Is anybody still using Windows XP? All right. Yeah, number one, that was an experiment in public shaming to see if anybody would raise their hand. But number two, if anybody had said yes, I was going to give you my colleague's business card who specializes in, we call them deathbed XP migrations. So in 2010 and going back to 2007, was a separate role. We didn't have a lot of guidance on how to implement it or where to implement it, but we could put it on a separate server if we wanted to, and it did its thing. Now, in 2013, it's not a separate role, except it is. Okay, let me explain. We got two parts, right? Now, like Ross said, friends don't let friends run single-role Exchange servers anyway, so filter everything I say about these separate roles through the lens of Microsoft's recommendation that you only ever have combined Mailbox plus CAS. So although these roles are logically separate, we will normally be running them on the same logical machine, whether that's a VM on a VM host or on a physical machine. That's a religious debate that we can have tonight after the whiskey tasting, but it doesn't matter. It doesn't matter from an Exchange standpoint. All right, then once we settle that, then we'll worry about Emacs versus VI. The CAS role, yeah, that's an old joke. The CAS role has a call router on it. And if you think about what the CAS does, it's just a proxy. Everything that the CAS does is to proxy a connection request from here to there. It doesn't store any data, it doesn't queue any data, it doesn't persist any data. When you think about it from that standpoint, the way that the call router works makes perfect sense. It accepts an incoming call request, it figures out where the optimal target mailbox server is, and then it proxies that using the SIP redirect mechanism. Now I'm going to talk a little bit more about SIP, and when I get to that point, I'll ask for a show of hands. We can talk in more detail about how SIP does what it does for those of you who are interested in it. But the key thing to keep in mind with the call router is that it doesn't do any media. If you spend time around Link people, you will learn that there's something called early media that you can have in a Link conversation. And basically what that means is, do the two endpoints start exchanging audio before the call has completely been accepted? You can think of that, how many of you are old enough to remember when Reagan was the president and he mistakenly, or not realizing the mic was on, made that comment about bombing the evil empire in 5 minutes, and everybody got all uptight about that? That's early media, right? So if you have early media on a Link connection, you can be carrying audio before the or sending audio that the recipient may or may not handle. That doesn't come into play for the CAS. So when the Link guys are talking about firewalls preventing early media and why that makes calls take a couple seconds to set up, we can just stop that discussion because we don't care for the CAS. It doesn't generate audio, it doesn't accept audio, it doesn't do any of that. On the other hand, the mailbox role actually runs the service itself. Okay, this is the service that does the work along with the worker process. There's a joke in the aviation world that eventually we'll have airplanes that have one pilot and one dog in the cockpit. Okay, the pilot is there to make sure that the autopilot is turned on, and the dog is there to bite the pilot if he tries to fly the airplane. Well, that's kind of what the service and the worker process do. The worker process does the work. The service is there to make sure that there is always at least one worker process running and to kick it or to change over if for some reason it stops. So the services that are on the mailbox side of the role actually do the things we think of as being related. They answer the phone, they handle the automated attendant, they produce media streams, they consume media streams, they record messages, they pass those messages to transport. Everything that Exchange 2010 did is done on the mailbox piece of the role. So if you want to think about it, if it helps, you could imagine taking the entire role out of 2010 and just moving it over to the mailbox server and then abstracting some portion of that and moving it back to the CAS, the call routing piece. So because you can and should combine these two, what does that mean from a traffic flow perspective? Well, it means exactly what you would think, that even though those two services are together, they're actually using different ports so they can coexist on the same box. And if you use Netmon or Wireshark and watch the traffic flow of a call, you will see that call come into the call router and then see traffic going from one port to another port on the same machine when they're combined to actually do the call routing. Now, one of the common questions I get is, okay, well, if this architecture has changed, we got all new sizing and architecture guidance for 2013, right? Why? Well, now that the roles are different, the resource consumption requirements are different. The scaling that's in the Exchange mailbox role calculator is very different. And the guidance we got from Jeff and his crew on the ELO blog is very different. On the other hand, the guidance that we got for unified messaging planning and scaling in Jeff's guidance basically boils down to a big donut. If your server is too busy, get a bigger server, is essentially what it says. Now, having said that, you can make the argument that the mailbox role in Exchange 2013 already uses so much RAM and so much CPU that how could possibly make it any worse? And I think that's fair. We still have the same limitation that Microsoft recommends a maximum of 100 concurrent calls. I have yet to see a customer, even a very large one, that had that sustained call volume. You may see spikes like that. For example, I have worked with folks who support a customer that does outbound notification for school closings. And so around those times when it looks like school might close, all of a sudden their call volume shoots up because parents are calling the school to find out, is school closed? How long do I have to get there to pick up little Johnny? That kind of thing. So they do have spikes where they get closer to 100 concurrent calls. But it'd be pretty rare to get up there and plateau. So from a scalability standpoint, what I will say to you is this. If you're using with 2013, you'll do exactly what you would do if you weren't using You're going to watch the performance of the server, and when it looks like it's performing poorly, you're going to get a bigger server. I'd love to be able to give you a formula or tell you that the next rev of the mailbox calculator will be smarter about but I can't. All I can tell you is buy the biggest server with the most RAM you can afford from Dell. Oh, wait, I'm sorry, did I say that out loud? Buy a big server with a lot of RAM, and you will be happier than if you skimp on those things. I don't have a better story for you than that. Or, Microsoft's standpoint is if you go to the cloud, you don't have to buy any servers at all. So this is actually Ross's diagram. I stole it. But it shows pretty neatly how the subdivision between these things break down. So if you look up here, see if I can arm this thing. Okay, if you look up here, these are all the different client access methods we have, including telephony. So telephony can be redirected to the component on the CAS, which is going to redirect it again. And what's not shown but should be is when the call actually gets down here, the component's running on the mailbox server. Okay, this is a somewhat simplified diagram, but, and it does. I couldn't see it from the angle I was at, but this blue dotted stripe over here shows the SIP and RTP, a real-time protocol audio data that goes from the originating endpoint directly to the mailbox server. It's just not drawn in the same color scheme, so I always forget that it's there. So what does this mean from a practical perspective? Well, now the call router is free to pass an incoming call to any mailbox server. Before, we couldn't do that. We could only route calls to UM servers. But now, because every mailbox server is a UM server, whether you want it to be or not, you have to think about what your topology for call answering will look like. In general, what I tell people, put every UM server in every dial plan. That allows any server to answer a call for any user. Exchange is always going to try to use the same site preferences we're already familiar with to pick out the best server to answer the call. But with a topology like this, where everybody is in every dial plan, then you never have to worry that you're going to be unable to answer a call, even if it's cross-site. Even if you have to answer the call on one site and then fetch the mailbox greeting from a different site, you'll still be okay. I'm going to talk a bit more about that a little bit later on when we talk about call origination and call routing. So let's talk about how the call traffic flows. So I have a Link server, which is representing our phone system. Doesn't have to be Link. It could be Mitel, it could be Nortel, it could be Avaya, it could be ShoreTel, it could be your Momtel, doesn't matter. It's some system is pushing phone calls into our network. We want to answer them, which means somehow the call router and the UM service are going to have to work together to get that call handled. So what happens first is that the originating PBX is going to generate traffic using one of two ports, either TCP 5060 or TCP 5061. Now, Link is always going to use secure SIP. Secure in this context just means it's SIP plus SSL. So it's SSL encrypted just like SSL encryption for OA or for any of the HTTP protocol apps that you're familiar with. So either way, that initial request is going to go to the UM call router. How does the PBX know where to send it? Because you've got to configure the PBX to tell it what CAS servers you want to receive calls. You don't configure that in Exchange because Exchange doesn't care. Every Exchange CAS can receive UM calls. So you tell your PBX, okay, I want all the calls that are coming from the PBX in Austin to go to OSCAS 01 through OSCAS 15. And I want all the calls that are originating in San Jose to go to SJC CAS 1 through SJC CAS 15. However you want to configure it. You could have all the calls go to Austin. You could have a load balancer. You can do anything you want to distribute that traffic. From the Exchange side, we don't care. When the call arrives at Exchange and we answer it, that's when we start caring about it. So the call comes in using either SIP or secure SIP. And the call router immediately issues a redirect. So if you're familiar with HTTP and HTTP redirection, this is exactly the same principle. There are a couple of different kinds of SIP redirect that can be issued, but in this case, it's a 302 moved temporarily. Right? So you're going to get, if you watch this traffic, you'll see the original call go to UM call router on whatever CAS the PBX is programmed to talk to. And immediately the CAS is going to come back and say 302 temporarily moved. Here's the IP address of the thing that I want you to talk to. Which means now the PBX is going to make a brand new separate connection. But it's okay because SIP is really lightweight. If you look at the SIP payloads, it's all ASCII text. It looks a lot like an SMTP command sequence. There's no audio data, right? So the overhead involved in having an extra redirect step is minimal. Because we only have to do it once per call. It's not like having some of the awful scenarios that Greg talks about with 2010 CAS and namespace planning. Here, there's one redirect, and then you're done. So the PBX is going to pass this call back to the UM service running on a mailbox server. Oh, wait a minute, look what happens. So it's going to get back another SIP 302 so that the call goes to the UM worker process. Now, I've got a table coming up in a couple of slides where I list out the ports. I don't really want to spend a lot of time talking about those because who cares, right? It's on TechNet. I don't need to reread that slide to you. But the key point I want to take away is that this traffic will flow over different ports depending on where it's coming from and what protocol it's using. It has to be that way because remember that the call router and the UM service can be smashed together in the same box. The important thing that you need to know is that you can change some of these ports, but you cannot change others of them. And the reason that becomes important is that some PBXs, for example, will generate SIP, but they won't use 5060 and 5061. They'll use something else. That happens to be one of the port ranges that you can change with set call router settings, although you can't currently change it in the GUI. On the other hand, the traffic that's going here cannot be the ports that are used to talk to the service or the worker process can't be changed. So look what happens now. The worker process actually answers this call request when it comes back with a 180 ringing and then 200 OK. And then we go through, how many of you know what SDP is in this context? Okay, if you haven't heard of it, SDP is the Session Description Protocol. It's a fairly verbose protocol that you can use for situations like this when you want to negotiate an audio exchange over RTP. So each end specifies what codecs they support, and they do a little dance, and they sprinkle some unicorn dust, and then you end up hopefully with a working audio connection. The case where you end up not with a working audio connection is spelled CISCO, if you happen to have a Cisco phone system. There are a few cases where they use codecs that Exchange doesn't recognize or won't negotiate with. And the problem is that on the Exchange side, you have no control over what codec Exchange uses. There's no set preferred codec or set Cisco interop mode commandlet. So when you run into that problem, if you do, the fix is generally going to be on the PBX side to make sure that it has at least one codec in common with Exchange. I don't see that as a problem very often, except in cases where the customer has got ancient legacy telephony systems. And generally, most customers who are in that boat are already in the process of jettisoning their phone system and replacing it with a more modern IP-PBX or with Link. So that problem tends to solve itself, but it can be a little frustrating until then because it looks like the call is being answered, and then when it's answered, you get no audio, and you can't figure out why. So at this point, the call's been established. We've gone from having nothing to having sort of the equivalent, these middle bars. You can think of them like the phone ringing because the signaling is going back and forth. And now the remote end has picked up the phone but hadn't said anything yet. So we've got a channel to pass audio over, but there is no audio actually being exchanged yet. Why? Because we don't know what audio to play. Right? We don't have any audio for the user's greeting, but we will. So here's a chart I promise. This is stolen directly out of my book, which was stolen directly from TechNet. I just worded it a little more clearly. So you can go back and look at this later. The presentations are on Yammer, by the way. Every time I say Yammer, y'all all have to drink. That's the game we play here. So you all owe me one drink tonight at the thing. Boy, that's good. Why cola? All right, so you can look at this later. And I want to talk for a minute about speech. So I just said the call's answered, but we don't have any audio or speech or anything. Before we can really dig into what happens with that audio, where it comes from, who generates it, what's in it, we need to have a brief speech nerd side discussion. So when you think about Exchange what it really is, what it originally started as, was as an interactive voice response, or IVR application, that originally was built on top of Microsoft's separate speech server product. Did any of you ever buy speech server? Yeah, nobody did because it wasn't for us. It was for companies that wanted to build applications. So it was more of a runtime than anything else. It got eventually baked into OCS and then carried forward into Link, and now Link is what you use if you want to build a telephony-enabled application on Microsoft's platform. There is no discrete speech service. Now, for those of you that appreciate puns, you won't like this one because it's pretty weak, but when I said discrete, that's actually a speech pun. No? Okay. Because there are two kinds of recognition that we see in speech systems. One is discrete recognition. If you've ever called an airline and had to say, reservation, that's probably because you're talking to a discrete system. It's listening for individual words, and if you talk too fast, or you don't pronounce the word in exactly the way it expects, or you have an accent, or there's a lot of wind noise in the background, then the system won't understand what you're saying because it's looking for one word at a time. A continuous speech recognition system does what you and I do when we talk to somebody. Unless it's my grandmother, when I'm speaking to someone, I don't have to wait for them to enunciate every single word before I can understand it. And with my grandmother, she speaks at such a high volume because she thinks everybody else hears like she does that I never have any problem understanding her, even when she's 100 meters away. At that point, she would say, bless her heart. Okay, so for continuous speech recognition, that means the system can interpret without having to stop and without making the speaker conform to what the recognition system is looking for. There are also speaker-independent and speaker-dependent systems. Anybody in here use Dragon Dictate? Okay, if you did, then you'd recognize what I mean when I say speaker-dependent. With those systems, you have to train them so that they understand your voice. And if you've trained them for your voice and your spouse or one of your kids or a coworker uses that same recognition database, they'll get very poor accuracy because the system is accustomed to the way you talk, how you phrase things, the pattern of your speech, the speed of your speech, and so on. So what we've got in Exchange is a couple of different applications of these technologies. The most interesting one from a technology standpoint is voicemail preview, because that is a speaker-independent, continuous speech recognition engine. Whatever you say, it will try to transcribe. Now, notice I said it will try to transcribe. It'll come up with something. All right? It may not be exactly what you intended. And you know, in all seriousness, I do like to make fun of voicemail preview, but it's an awfully easy target. And the fact is that its recognition accuracy for most languages is surprisingly good, considering what it's for. Remember this morning when Jeff was talking about, or Harv was talking about intelligent triage? Well, that's what this is for, right? This function is for me to be able to pick up my phone in the middle of a session or the middle of a meeting or in someplace else where I can't put it up to my ear and listen for voicemail. And I can quickly scan, oh, hey, I've got a message, and hey, it's a voicemail, and hey, it's from my son's school. And the text, it may not give me an accurate word-for-word rendition, but it's good enough to tell the difference between your son Tom burned his arm off in metal shop today, because boy, he loves that blowtorch, and I worry about him, versus Matthew's running low on lunch money, can you drop a check off? It may not give me an exactly accurate, but it's going to be close enough for me to tell, hey, do I need to jump on a plane and fly back to the burn unit, or can I just PayPal some money to the school? And that's what voicemail preview is for. It's for triage. It's not necessarily for getting every atom of meaning out of the message. The traditional things that we think of as being like IVR applications are like Outlook Voice Access. You call in, it says, welcome to Microsoft Exchange, and you can say, open my mailbox, or open my calendar, or directory. If you say, well, I need to call Joe, and I can't remember her phone number, so please get the directory for me, it's probably not going to pick the one nugget out of that entire stream, okay, because it's a discrete speech recognition app at that point. So I mention this because sometimes people get confused about why they have to enunciate and pick individual words in some modes of Exchange UM, and in others, like voicemail preview, you can just talk and go. Oh, you know what? One other acronym that we might need to touch on. TTS just means text-to-speech. So it's the opposite of ASR. With ASR, I talk and the computer extracts some text from that. With TTS, I feed it text and it comes out as voice. This becomes important because the set of languages that Exchange can do TTS with are not the same as the set of languages it can do ASR with. And in fact, the languages it can do discrete ASR versus continuous ASR are also not the same. How many of you work for companies where there is more than one global language used by your workforce? Okay, keep your hand up if there are more than 2 languages. More than 3? Okay, that's about what I expected. Most of you are going to be dealing with environments where you have one primary language, and you may have little pockets of additional languages. And that's sort of the use case that UM is optimized for. So I want to talk for a minute about how calls flow in this environment. We already talked about the incoming call arriving somewhere. We don't care where, we don't care how it got there. It goes through the phone system, or it comes from a PBX, or it was, I don't know, and it doesn't matter. Link, or the PBX, is then going to try to place a call to the recipient's phone and make it ring. Notice that steps 1 and 2 have nothing to do with Exchange. And neither does step 3 until the end of it. So every PBX will have, if it's not called a call coverage map, it'll have something like a call coverage map that says, okay, when someone calls extension X and it's busy, do this. If they call extension X and it's not answered, do that. In Link's case, it's always going to busy no answer, send the call to voicemail. Okay? Other PBXs may have other things you can configure. But whatever the case, when the call is either busy or not answered, then the phone system piece of this pie is going to move the call over to the call router. The call router is going to figure out, okay, what mailbox server is best for this call? Where's it going? What's closest in sight to where I am? That's where I want the call to go. It will redirect the call. The call is answered. Now here's where the audio that I was talking about earlier comes into play. When the call is answered, obviously the system has got to have some audio to play back so that the caller knows that they've reached Paul Robichaux's mailbox or Bill Gates' mailbox or Kate Upton's mailbox. They've got to have some indication of that, and that prompt is what generates it. If you don't record a prompt, then the system is going to synthesize one using text-to-speech. That means if you have an unusual last name, Exchange is probably going to mangle it. It's a computer. It doesn't know the rules for pronouncing Cajun names like Robichaud. Or Polish names, like Wisniewski. It's going to do the best it can. If you don't like that, record a greeting. Problem solved. At that point, once the greeting has been played back, and I guess I should mention also that this greeting playback does not have to come from an individual user. Okay, notice these steps 5, 6, and 7. I'm guilty of kind of muddying the water a little bit. Here, this call could actually be for an individual or for an automated attendant. And these steps are the same. Either one, Link or the PBX is going to send the call to the extension that belongs to that object. The call router will figure out where it goes. And then when the server actually receives that call, or when the mailbox server receives that call and wants to do something with it, it's going to retrieve a greeting. I've been talking about it as though that greeting is always going to come out of a user mailbox, but it doesn't have to. It could be a set of prompts for an automated attendant, and we'll talk about how that answering case differs here in a few minutes. At that point, once a greeting has been played, we give the caller an opportunity to do something. She can record a message if it's, if it's a call to an individual user. If that user has call answering rules enabled, she may have some DTMF or voice choices she can make to make things happen. If it's an automated attendant, she may have some routing choices that she can make. Or she may just have the option to leave a message and then drive on from there. So this raises the question of how does Exchange know what greeting to fetch in the first place? Okay, how many of you are familiar with the concept behind proxy addresses? Okay, it's a little mysterious because Microsoft doesn't talk about it a lot because why would you? It's just a proxy address, just like SMTP proxies. So if I phrase that question differently and say, okay, how many of you are familiar with Exchange proxy addressing? I bet everybody will raise their hand, right? We all understand that an addressable object can have multiple proxies with different address types. Especially if you worked back in the days of 5.5 and you had, the notes proxy address type or X400. Anybody remember that? That makes me want to vomit every time I think about it. Okay, well, turns out Exchange is just a different type of proxy address. It's prefaced with EUM : instead of SMTP : or whatever, but it's exactly the same. And the reason we need it is that when we get the incoming call, all we have is the extension that was dialed. So let's say my extension is 7285. My mailbox server gets that call request, and it's got a SIP, what we call a diversion header. And the diversion header says who the call is coming from. It says that the call originally came from the PBX, but that it was for extension 7285. Well, think about it for a second. The mailbox server has no way to know that extension 7285 belongs to me, except that it can take 7285, tie it to the dial plan that server is in, and then now it has something that looks like 7285 at some dial plan.worldsbiggeststartup.com. That's a useful combination because it can do an attribute search against AD. So the EUM proxy address is an indexed attribute that gets stored in the global catalog for every enabled user. That way, the mailbox server can efficiently do a reverse search to say, okay, I've got a call for extension 7285. What mailbox GUID does that correspond to? Once it has a mailbox GUID, we're done. Because then it can connect to that mailbox, retrieve the greeting if there is one, and then play it back. The greeting, by the way, is going to be stored as a folder-associated item or an FAI in the root of the mailbox. So users can't see it directly. You can't see it directly, but you'll see it if you run any kind of MAPI inspection tool. Right? Anything that shows you the FAIs will show you all of the related items, including call answering rules that are in the user's mailbox. So just to give you some sense of what this actually looks like, notice that all I did here is I ran get mailbox. Right? It's a command that we probably all use many times a day. And I said, show me the name and then email addresses, multi-valued attribute. So look what I have here. For Sam Colt, he's got EUM 7001, blah, 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 huntsville.worldsbiggeststartup.com. And he also has an SMTP address. Same thing for each of these additional users. Okay? So the EUM proxy address is just another address type that gets added into the existing email addresses field. It's not separate. It's not magic. Anything you can do to modify the SMTP proxy address, you could do to modify the proxy address. So at that point, once the caller has recorded a message, there's a whole bunch of other stuff that can do. Right? It can protect the message with IRM. It can take the number that came in with that diversion header telling us who called, and it can try to resolve that against the user's contacts folder or against the Active Directory so that the message appears to be from John Smith instead of from 256-555-1212. It can do voicemail preview transcription, which we'll talk about later. Once it's done processing the message according to what the caller has requested and according to what the policies that you as an administrator have set, then the message gets handed off to transport, and at that point we don't care about it anymore. It becomes a transport problem to deal with. I probably should move this message waiting indicator up a little bit because this normally happens before the message. It can happen before the message is submitted, but typically we want it to happen after the mail has actually been delivered so that the light stays in the correct state, right? I'm trying to remember, I think I took the MWI slides out of here. I'll be happy to talk more about MWI if you guys are interested because the technical implementation is actually pretty cool. But from a feature standpoint, it's very simple. It either works or it doesn't, and there's not really anything you can do about it. But I've had customers who refused to deploy Exchange 2007 because there was no native way to make the light blink. I think that's crazy, but there it is. So let's talk about these objects. The objects that are in Exchange are named after their telephony equivalents. That's why in Exchange, for example, we have something called a hunt group. And it does not mean a bunch of dudes with guns. It means mailbox users with guns. I like that even less. It comes from back in olden days when telephone switches were electromechanical. There used to be this thing called a crossbar switch. How many of you have ever seen a pin plotter? Okay, I mean, I realize it's very old school, but if you've ever seen one, you know that it's got a pin that is in a cradle that has two sets of stepper motors that can move the pin vertically or horizontally. And so the pin will move. It's almost like an Etch-a-Sketch. The pin will move here, and then it'll move over here, and then it'll draw a line, and then it'll pick up and move up here, and then move over here and draw a circle, sort of. Well, that's what a crossbar switch is it actually had this electromechanical carriage that sounded like the carriage on a typewriter that would hunt from one bar to another until it found the right contact to connect to the desired number. So Exchange doesn't actually have that. Just to let you know, there's no crossbar switch hidden inside your mailbox server, although that would account for its performance. I kid because I love. But we still call them hunt groups. So the same thing happened with Link. Link has dial plans, and they have nothing to do with Exchange dial plans. Right? An Exchange dial plan is very close to what we think of as a dial plan on the PBX. But there's a bunch of other stuff smashed into it too. Dialing rules, for example. What kind of outbound calls are objects in this dial plan allowed to make? Okay, that kind of sounds like something dial plan related. Automated attendants, do they belong to a dial plan? Yeah. What kind of dial plan, what kind of numbers are in this dial plan? Numbers is a poorly chosen word in this context because your dial plan may be a telephone dial plan, in which case it can have any numeric digits in an extension. It can be an E164 dial plan, which means it has to follow the E164 number normalization rules. Do I have any Link admins in here or people who have worked with Link? Outstanding. So I don't need to spend any time explaining E164, which is good because I don't really understand it. Or they can be SIP, in which case the extension is actually going to be something like SIP : Paul_Robichaux@Dell.com. Okay, when you have a SIP dial plan, there don't have to actually be any numbers in your phone number, which is a little weird until you get used to it. On the other hand, what the Link dial plan specifies is how do I normalize an incoming or outgoing number for this dial plan? Do I add an area code to it? Do I have to add +1 and a country code to E164 it? Right? Probably half of Lync Enterprise Voice pain comes from dealing with dial plans and making sure that the number you get out from your normalization rules matches the number you want given a certain input. We don't do any of that in Exchange, right? Because Exchange doesn't do number normalization. That's a phone system thing. What we do, we answer the phone. It used to be the case that we had to have matching names on our Exchange and Lync dial plans. That's not the case any longer. So that's all I want to say about that. Instead, well, that's bizarre. So this slide should not be titled User Greetings. I looked at that and I thought, wait a minute. Got off my cognitive railroad there. There is some integration that we have to do to make Exchange work specifically with Lync. And the big thing to keep in mind for that is that Exchange needs to know that it is okay for it to accept calls from Lync, which we do by creating UMIP gateway objects for each of the Lync servers that can originate calls. And then we have some stuff that I think I have slides covering later on the Lync side to tell it that it's okay to trust Exchange as a place to send calls. Now, there are a couple of tricky parts to that because Lync will try to do that for you in some cases. And if you go back and do it yourself after Lync has already done it, Lync will stop answering calls from those servers. This is typically the case that you see when OA integration with Presence works, and then you set some stuff up to make it work, and then it doesn't work anymore because you broke it, because Lync was already trying to be helpful. The other thing, notice what this does. The integration steps create a hunt group for each IP gateway. Okay, in the Exchange world, hunt group's just a container. It doesn't do anything, and I expect eventually it'll be deprecated because it doesn't do anything. Now, and I realized what must have happened. The slide before was supposed to talk about how the audio greeting was for the user was stored in the user's mailbox as an FAI, and that they could have either a full greeting or just the name, right? Because Exchange will ask you when you set up a new mailbox to record your name, and then it will also ask you to record a greeting. If you just do your name with no greeting, the system will play a TTS prompt and stick your name in it. You've reached the Exchange mailbox of, and then it'll play your name. Please leave a message after the beep. Or the localized equivalent, whatever language it's using. If there is a full greeting, it will use that. If there's not, it will use a recorded name. If there's none of that, it will synthesize the entire greeting along with your name. But when we start talking about automated attendance, things are a little different because we still have these greetings that we want to be able to play back. But where do they come from? Well, it turns out that they come from the arbitration mailbox. Okay, this is different because in 2007, we had a service that replicated this stuff for us. In 2010, we had to be able to import those prompts from the replicated stores where they were kept and put them in arbitration mailboxes. In 2013, we find that, oops, now we have a bunch more arbitration mailboxes for the new discovery stuff. So how do you know which one it's in? It turns out that the arbitration mailbox has a property called persisted capabilities. And this name's a little confusing because it seems like it should be more like persistence capabilities, or what's in this arbitration mailbox. Because what you see when you run get mailbox with the arbitration flag, and you look at persisted capabilities that are like you'll see here we've got organization capability grammar ready, and organization capability data storage. And then notice this one, with the GUID ending with DC 928C, it's got a bunch of other additional capabilities listed. Whereas this one only, the ED9 arbitration mailbox, only has the capability of prompt storage. So organization capability grammar means that the mailbox can be used to hold the grammar that's generated by the GAL grammar generator. How many of you are familiar with grammar generation in 2010? Okay, this is another one of those invisible things that mostly just happens out of sight, and as long as it's working, it's great. And when it doesn't work, and you go to look for documentation, you find there isn't any. And so you call CSS, and they give you some magic incantations. Anybody done that before? So capability grammar means that that arbitration mailbox could hold grammar data. grammar ready means that it does actually have a generated grammar in it. This becomes important at the time when you have to remove a corrupted or damaged arbitration mailbox and recreate it. Because once you recreate it, until you see that it says grammar ready, that means that there's no grammar, which means that automated speech recognition for things like dial by name won't work, because there's no grammar for it to use to interpret what you're saying. Capability data storage is what tells us where the automated attendant prompts actually live. Why do we care about this? Because if this mailbox doesn't exist, or if it's damaged, or if a server cannot get to it, that server will not be able to answer any automated attendant calls. And what will happen is that the system will answer, try to fetch the prompts and fail, and say, your call cannot be handled at this time, goodbye, and hang up. If it turns out that people are calling your company's main number and they're getting that response, probably not what you want. So, grammar generation. Let's talk about this briefly before we move to talk about automated attendants. In earlier versions, there was actually a utility we could run called Gal Grammar Generator. You would run it. It would generate the grammar. It would put the files either in the location where the FRS would look for them or into the arbitration mailbox. We don't do that anymore. There is no longer a Gal Grammar Generator tool. And when you look for it on TechNet, you'll still see some documentation that references it. But that's just a tease. It doesn't exist. You can't use it. Okay? And if you try to get the 2010 version and copy it to your Exchange 2013 server, you deserve what you're likely to have to deal with. I'm just saying. So what happens now is that the Gal grammar is generated by an assistant that runs on the mailbox server where the target arbitration mailbox is stored. How do you know which one is the target? You look for the one that has capability data storage. Okay? I'm going to leave it as an exercise to you guys to figure out how you figure out what mailbox server database hosts that mailbox, but I'm pretty confident you can all do it, or you wouldn't be here. So that's where the grammar data is going to go when the generator runs. It's going to automatically run at 2 a.m. local time according to where that server is located. Or you can change that schedule using set call router settings. Now, please don't ask me why you use set call router settings to change a setting that only has an effect on the mailbox server. I don't know why. Maybe that'll be fixed in a future version. But for now, if you want to change that generation time to another time, you can. It is claimed that if you stop and then restart the mailbox assistant on the target server, that will force it to regenerate the Gal grammar. I've seen cases where that worked, and I've seen other cases where it did not work. So I would not necessarily bet on that doing the trick. What will force it to regenerate is if you remove the arbitration mailbox, recreate the arbitration mailbox, and then stop and restart the mailbox's system. But that's kind of a lot of work to go through. That then raises the question of why would you want to regenerate the grammar? And typically, the answer is because new users are not showing up fast enough. Because remember, the grammar is what the system uses. Actually, I'm getting ahead of myself. Let me save that for the language discussion. Suffice to say that if you're patient, you don't generally ever have to regenerate the grammar. If you're impatient, you may want to generate it more frequently, but you can probably get away without having to do it. So automated attendants, receptionists in a box, whatever you want to call it, this is a system that lets us set up a call tree so that when a user is transferred to the entry point of that attendant, they get a series of choices that let them say or dial things that will result in a couple of different possible outcomes. One is that the call will be transferred to an extension that belongs to a person. One is that the call will be transferred to another automated attendant. It is possible to set up automated attendants to do out calls, but very few people do that because the risk of allowing people to dial arbitrary numbers is generally not worth taking. And you can provide dial by name. So the automated attendant gives you a way to say, thank you for calling Contoso. If you know the name of the party you wish to reach, say it now. Otherwise, press 1 for sales, press 2 for customer service, press 3 for legal. When you press 1, that call can be transferred to the sales extension, or it can be transferred to an automated attendant that belongs to sales that says, thank you for calling the Contoso sales department. To buy something, press 1. To sell us something, press 2. All right, so you can chain these together. You can use chaining to do multilingual attendants. Okay? Press 1 for English, press 2 for Spanish, and so on, where each choice that the user makes just branches to a different automated attendant. We also have some, some fairly simple but still useful options for business and non-business hours. So you can play a different greeting that says, "Happy holidays and thank you for calling Contoso. We're closed for Christmas," and so forth. The automated attendant itself, did this thing quit working? Okay, I'll just talk louder. So the thing about automated attendants is that from an exchange perspective, we mostly care about their operation as revealed through... Okay, so this is working. I'm just not being loud enough or something. Okay, so the thing we care about for automated attendants is where they're stored and what they do, right? We've already talked about what they do. Where they're stored, it turns out that all the automated attendants are in a container that's visible throughout the entire org. And I put the path up here so you can go look and see what's in there if you're curious. But just because the automated attendant is visible to every server doesn't mean every server can use it, because the automated attendants are grouped according to dial plan. So the server can only play, if you will, an automated attendant that is assigned to the dial plan that server is in. So what's in it? Well, we've got a language binding, which I'm going to talk about more in a minute. We've got custom prompts, if you have recorded them. We've got a set of mappings that specify what should happen when different digits are dialed, or when the when the caller says something particular. And then just a bit vector that specifies what holiday and business hours are for that particular attendant. So you actually, on different attendants in different dial plans, you can have completely different business hours or holidays specified if you want to. That can be useful if you've got dial plans in different countries or different regions where they may have different holiday or business hour requirements. So, languages. We call it a language pack. There's really more than one piece to it. There's an acoustic piece. There's a statistical model that the system uses to predict what you're going to say. And then there are prompts and grammar. It doesn't do punctuation, so you don't speak to it the way you would speak to Siri or the way you would speak to Dragon or another system where you say, "Hello, comma, mech attendees, exclamation point." Okay? Those dictation systems are great for dictation, but this is not that. The prompts and the grammar come from Microsoft, or some of them come from Microsoft. They're already pre-recorded, usually in multiple languages. They sound pretty good. And we don't have to do anything with them. They come pre-installed. It is not supported, although it is possible for you to go find where all the WAV files on your server are and customize every single prompt. But as soon as you do that, remember the first time you install a CU or a service pack, you're going to lose all of those customizations. So I'm not sure that I would bother. There are also prompts that you can record yourself for business hours and things of that nature, right? Like the initial greeting for an automated attendant. You probably don't want it to say, "Welcome to Microsoft Exchange." You'll want to say, "Welcome to Litware," or "Thank you for calling Tailspin Toys," or whatever. That's one of the prompts that you can record. So there are, I think, 26, but more than 20, fewer than 40 languages that are supported in the form of language packs. Out of those, only these languages are supported for voicemail preview. One of the very common questions that I run into out in the world is, why isn't language X supported? Okay, you look at the list and you look at the number of people who speak these respective languages. It's reasonable to ask why Polish is on there. Okay, there are not as many people who speak Polish as there are people who speak UK English, for example. So that's a fair question. But it turns out there's a good answer. If you look at this green bubble up here, what this chart is showing you, and this is fairly old data because this predates the release of Exchange 2010 by a few months, but the general relationship still holds true. If you look at the vertical axis, we have a usability or a rating scale where users rate something as a 1.0, which means terrible, to 5.0, which means awesome. Right? And then the accuracy of actual recognition. Well, look here, and you'll see that recognition accuracy was low for Canadian French, and the test subjects hated it. Yeah, well, I mean, number one, nobody's going to want a tool that is really bad at recognizing their language. But particularly, and I say this as a descendant of French Canadians who got thrown out of French Canada and ended up in Louisiana, these folks are very particular about the quality of their language. And so, yeah, that's why it's way down here. Then look at some of these other languages. I mean, Great Britain, the UK, That's probably Microsoft's second or third biggest worldwide market. They would really, really, really like to have great voicemail preview quality. But the fact of the matter is they don't. Right? The best they can do right now is just shy of 60%, and it gets about a 3.0 rating. Not great. I wouldn't ship it if that were me. So if you look at the languages that are in the bubble, the ones that tended to score best are the ones that got shipped. Now, what makes, what gets you up here? Having more data to put in. It turns out there's actually a logarithmic relationship between the amount of audio you stuff in and how good the recognizer can get. So doubling your recognition accuracy takes much more than doubling the amount of audio that you feed in. So how many voicemail messages do you think Microsoft has in Danish, let's say, that they can use to improve their recognizer? And it's kind of self-fulfilling because they don't support voicemail preview for Danish, they're not going to get a lot more voicemail data in Danish that they can use to improve voicemail preview. So there's a feature called voicemail collection that you can opt into where your voicemails will be sent to Microsoft so they can use them to improve these recognizers. The problem is that the vast majority of people who have voicemail deployed with Exchange UM are sending more data to make US English better and better and better, which is not necessarily what anybody else outside the US wants. So what about dial plans and languages? Remember I said before that the dial plan actually acts more like a policy? That's because the language you set as the language for the dial plan controls how the system interprets and generates language for everything else that it does. So if you set the dial plan language to US English, if somebody calls and leaves me a voicemail message in Russian, the system is going to interpret it as though it were US English because you've told it by setting the dial plan language to do voicemail preview in US English. Do you think that's going to produce a usable result? Probably not. It might be funny, but it's probably not going to be usable. What language is generated for prompts in Outlook Voice Access? What language is used for text-to-speech and automated attendance? All these things are driven by the dial plan language, and you only get one language per dial plan. So what that means is if you want an environment where you have multiple languages available, you're going to have multiple dial plans and put servers in them according to where those servers are and where the users who are using them are. Boy, every time I give this presentation, I promise I'm going to finish on time. And you know what? Not happening. Sorry. But I told the girl outside to lock the door, so it's all good. Wait, that came out wrong. I meant so we wouldn't be interrupted, not so you guys were trapped. Besides, you all have free tablets, right? You have something to do if you get bored. So, call answering rules. Cash money feature. If Microsoft sold these for Office 365 alone, they'd make a ton of money. Because this is a way that you can set up a rule to keep people you don't want to talk to from talking to you. Right? It also has some more benign uses, but when you think about why people deploy Exchange UM, it's because they want something answering their users' phones. This is a way to extend something very similar to Outlook rules to the telephony space. So that you can create a rule that says, okay, when somebody calls me, if it's my attorney, send them to voicemail. If it's my kid's school, ring my cell phone. Okay, that's just one of the many things you can do with it. Lync has got a similar feature called response groups that are much, much, much more complicated. This is a way for individual users to be able to customize things. So I can, for example, create a call answering rule that says if someone calls and they are one of the following people, my mom, my girlfriend, any of my 3 sons, my next door neighbor who's watching my cat, then it will automatically find me on my cell phone at the number I've specified. If it's anybody else, it's going to go to voicemail because I'm not talking on the phone right now, I'm talking to y'all. So that means if my phone rings right now, I can guarantee it will be somebody that I want to talk to, if at least briefly. Is the house on fire? No. Is the cat dead? No. Are you in detention and can't get out? No. Okay, great. I'll talk to you later then. All right, I can very quickly triage that call. So every user gets up to 9 of these. There are none by default. This feature is enabled by default, but it doesn't do anything when there are no rules. So when you think about how Outlook rules work, same deal here. The number one rule is evaluated. Its conditions are checked. If they match, the action is taken. If they don't match, the next rule is evaluated. That keeps going until we either run out of rules or until there's a match. The rule itself has got 3 parts. It's got 1 or more conditions that determine whether or not that rule will be matched when something happens. It's got an action, which is what's supposed to happen when the conditions match. And it's got a greeting or a menu, which is what you want the system to say when that call comes in. So let me show you a quick example of what this looks like. I'm defining a new call answering rule for one of my test users. It says if the caller is Amelia Earhart or Annie Oakley or Clara Barton or Eli Remington, then give the caller these options. Press pound to leave a voice message or press 1 to find me. So I can actually record a greeting that says that. And there's a separate part of the rule where I set the number that I want find me to actually use. It's not arbitrary, right? So if the person who calls in has a phone number or SIP extension that matches one of these 4 people, this is the choice they will get. If anybody else calls and there's no other rule defined, the only thing they can do is leave a voice message. Or maybe they match another later rule, right? Maybe I've got another rule that says if Sam Colt calls, then, I don't know, say something funny. So by default, no rules means no answering. So people can only leave voice messages. Now, when we talk about the actual conditions, these are surprisingly flexible. You look at them and you think, okay, well, that's 5 conditions is not very many compared to the, 40 or 50 of them that we have in Outlook. But each of these has got some nuances to it. For example, for caller identity, we can base our decision on the presence of a person in our personal contacts folder, the presence of a person in AD, or a specific phone number. So I can put in the phone number of my kid's school and have it match, but I can say if my son's math teacher calls, or the main number for the school, or after-school tutoring, or the piano teacher, treat all of those people as the same for the purposes of this rule. I don't have to have separate rules for each of them. Time of day, this is actually very cool because I can say if I get a call with an identity of my boss and it's outside working hours, then I can choose to have that call routed to my cell. Okay? Luckily, I don't have to do that, but I could. Free busy status. If my free busy status says that I'm busy, send all calls to voicemail. That would be kind of a nice thing to have, right? If I'm out of the office, automatically transfer my call to my assistant or to whoever on my team is picking up my Slack while I'm out of the office. You start to see how these can become more useful, even though this initial list of conditions doesn't seem that great. Then, we have a couple of other things that come in handy. We can create a rule that has no condition, which means it matches every call, which means you can create a rule that says, I never check my voicemail, so if you leave me a voicemail, I probably will get it eventually. Your best bet to reach me is to use IM or to send me an email. Create that rule with no conditions so it plays that prompt. Turn off the ability to leave a voicemail, and you've got exactly that. Or you could create a rule for a user who has left the company that only allows people to transfer to the operator. You don't want them leaving messages for somebody who's not there, right? And using Find Me doesn't make any sense. So if you want all of your users to have a consistent presence on the phone, this is a pretty good way to do it, especially when you consider some of the tricks you can do with actions. Now, right now, we only have 3 actions. Find me, meaning call some number I give you, transfer the call somewhere, or leave a voicemail. You can see there are a lot of other actions that Microsoft could potentially add, especially in combination with Lync. So adding more conditions and more actions over time, I think we're going to see this feature become closer to Outlook in terms of the amount of flexibility that we have. When the caller gets these choices, it sounds just like an automated attendant. So press 1 to find me, press 2 to leave me a voice, or press pound to leave me a voicemail message is a good example of what that looks like in practice. If you don't configure an action, okay, I call this the ex-wife rule. If you don't configure an action, then when the caller calls, the condition matches, but there's no action, so it doesn't do anything. If you record a prompt, then UM will play the prompt and then hang up. If you don't record a prompt, it'll say, you've reached the mailbox of Paul Robichaux, please call back later, goodbye, and hang up. This is a great rule to have if you have persistent calls from people that you really don't want to talk to. Internal, external, doesn't matter. Because think about the identity conditions. Match a phone number, match somebody in AD, match somebody in your contacts folder. Tired of getting telemarketed by the Red Cross? Put the Red Cross entry in there. You'll never hear from them again. On your office phone using Exchange UM. I can't help it if they call you at home. One of the cool things that we have access to is the ability to create and manage these rules with Exchange Management Shell. What that means is you can come up with a template that sets rules that you want people to start off with and give everybody those rules at the time you provision their mailbox by using a Commandlet extension agent hooked up to New Mailbox or Enable Mailbox. Because the rules are stored as FAIs, when the mailbox moves, so do the rules. That means that if you are now on-prem and you were thinking about moving to hybrid or cloud UM, the rules that your users define will go with them when you move them. So, very simple example. I want to get all the UM mailboxes and create a rule that says, okay, if the user is out of office, okay, notice that there are no actions defined, and the only condition is this schedule status. If the user calls, or sorry, when someone calls that user, if they're out of office, it's going to say, please call back later, goodbye, and hang up on them. It's rude, but I'm not trying to use this to generate business for you. I'm trying to use it to show a simple example of how you would do this. The actual conditions that you use, the format is semi-documented on TechNet. It's not straightforward. What I typically tell people to do is make the rule look the way you want it in the GUI, and then use get call answering rule or get UM call answering rule to see what it looks like, and then you know what to use for set UM call answering rule. So when do you use them versus link routing group? We don't care because we're not really talking about link. So let's talk about routing instead for a minute. We've got plain outbound calls, which is when the UM server just makes a call and plays some audio. Play on phone, basically. In that case, it initiates a call request using SIP because it's making a call just like you make a call when you use Link or a voice over IP phone. Then we have supervised transfers and blind transfers. And the difference between these is that with a blind transfer, we start the call, or Exchange UM starts the call transfer request, and it does not hang around to see if it succeeds. If you've ever had somebody who said, talking to them on the phone, oh, hold on, I need to transfer your call, and you hear beep, 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 and then you get a dial tone, that was a blind transfer that went bad. They hit transfer and then a number, and then they hung up without waiting to see if the other end picked up or not. Okay? So we generally prefer supervised transfers as humans because then we can hear what the, we can make sure that our call is getting answered. But Exchange only uses those for find me's. So the way that this flow works is that when you find me in a call answering rule, UM will ask you for your name. So you'll say Paul Robichaux or Joe Smith or whatever. Then UM is going to play a comfort tone. This is another leftover telephony word. It just means that you'll hear doot, 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 doot. UM is making a noise to let you know that it's still there. Right? It's like whistling when you walk through the graveyard, so everybody will know you're a live person and not a ghost. Or something. Maybe not the best metaphor. Then UM is going to use SIP to generate an invite and send it to the phone system, which will then initiate the rest of the outbound call. If that call is answered and the audio negotiation and RTP setup all go the right way, then when UM is able to start playing audio, it's going to play your name, or sorry, the caller's name that they recorded. So if you answer the call and say hello, it'll say you have a call from Joe Smith, press 1 to accept. If you don't answer the call, or if voicemail answers, nobody's going to press 1. So if the system doesn't hear the recipient of this call pressing 1, then it'll go back to the caller and say, couldn't find him, would you like to leave a voicemail? I'm paraphrasing, but that's what it does. On the other hand, if you do press 1, then SIP actually transfers your call. This is kind of like making a three-way call on your phone where you're talking to two separate conversations. First you call the first person, you put that call on hold, you call the second person, and then you join the two calls. That's what this SIP refer does, is it's joining the original call that the caller made to the UM server with the second call that the UM server made to you. When it joins those two, the UM server isn't part of the call anymore. It drops out. Now it's just the caller talking directly to you. Does that make sense? Play on phone is sort of a special case because it's not a transfer as much as it is an actual telephone call that's created. And the thing to remember here, where I see people run into trouble, is that you have to remember, if you can't dial that phone number from the phone on your desk, you're not going to be able to dial it with Play on Phone either, probably. What I mean by that is that people will get into a situation where they click Play on Phone and they put in a phone number and the call doesn't go through and they can't figure out why. Well, it's because they put the wrong number in. right? They added a digit, they left a digit out. That's one common case. Or they're dialing rules in the organization that says, sorry, you can't play on phone to a phone number in Hyderabad when you're actually in the Austin office. Or when there's something on the PBX that blocks that call from completing. So you've got to have the right number. Exchange dial plan has to be set to allow that number to be dialed, and the phone system has to allow that number to be dialed, or play on phone won't work. Okay? 100% of play on phone problems I encounter in the field relate to one of those three things. Most often, it's the user fat fingering the number. And when I tell them, okay, well, try your cell phone and see if you can dial that same number. Oh, no, I can't. Okay, that was the problem. Oh, the other troubleshooting thing to try, can you use another number for play on phone? If that number doesn't work and it also doesn't work for your desk phone, try a different phone number and see if there's something about that particular number. Maybe you can't dial numbers in France from wherever you're located. Or maybe you can't. There's something about that number pattern. I've seen bad normalization rules on the Lync server break this unintentionally. I've seen dialing restrictions that were put in place for tests and then never removed break it. Lots of different possible causes, but generally these two tests together will help you pin it down really quickly. So I hope in your evaluations you all point out that I didn't talk about cloud until the end instead of starting off with it like everybody else. Yammer. Because, you know, you can't talk about the one without the other, right? So the most common hybrid topology is customers who've got Lync on-prem and they want to move Exchange to the cloud. Microsoft has done a really good job of convincing people that mailboxes are commodity, and so it makes sense to put them in the cloud because that's cheaper. But to get full functionality from Lync and get all the enterprise voice goodness, you've got to have Lync on-prem. Thus, the frequency of this combination. So what you need is Lync has to have something called a hosted voicemail policy that tells it, remember earlier we were talking about how the phone system has got to be programmed to know where to send calls when nobody answers? When Lync, you do that with a voicemail policy. Lync's already got a voicemail policy and the call routing app that will route calls to Exchange for you. But if you're using Exchange in the cloud, whether it's on 365 or from a hosting company, you've got to create your Lync hosted voicemail policy, which is not the same as a Lync hosting policy, in order to tell it where to send those calls. This is driven for an individual mailbox by the value of this MSXUC voicemail settings attribute. That specifies for an individual user, for Larry or for Carrie or for Paul, where should that call go when the user doesn't answer it? And the key here is that what it's really telling you is who set the value. Okay, that's actually the most important part of this. And why do I say that? Because if we didn't include that attribute, then Lync wouldn't have any way to know whether it should pay attention to its setting or to the setting on the actual mailbox that tells the whole rest of the world what mailbox server that mailbox is hosted on. So if you want to let Lync route your calls to a hybrid voicemail target, you need to use set CS user hosted voicemail true for every one of the users who are having their mail answered by that hybrid. What this means, though, is that you could have a group of users. Imagine that everybody in this room works for me at Contoso. Everybody over here can be using on-prem Exchange UM, and everybody over here can be using hosted Exchange UM in the cloud, as long as I make sure to use set CS user hosted voicemail for this side of the room. Okay, as long as you remember to do that, you'll be good. But Lync will still have a hosted voicemail policy that specifies where those calls get sent. So not only do you have to enable the users whose voicemail you want to be hosted, but you need to apply a policy to those users that specifies the target. So in this case, our target is always going to be xap.um.outlook.com if we're using Office 365. Okay, you can think of it like the well-known endpoint. It's like m.outlook.com for configuring mobile devices. But the nice thing about Lync is that its policies are granular enough so that we can set a global policy, a site policy, or a per-user policy, and then grant that to users. So I could say, all right, I'm going to consider everybody over here in the Austin site, and everybody over here, since you are to my left, you're going to be the West Coast. So everybody over here is my Sunnyvale site. Everybody in Sunnyvale gets a policy that says you're using on-prem, right? which in this case actually means you don't get a hosted voicemail policy, whereas all my Austinites do get a hosted voicemail policy on their Austin site. Okay, I don't want to get into the details of when you would use each of these granularities of policy, because what we really care about is just remembering that you have to have that policy in the first place. So suppose that you wanted to have the shortest possible explanation of how to set this up. This is what you would do. Configure your link edge, which is going to require sacrificing some chickens. By turning on federation, letting the CMS replicate to the edge, and then creating a hosting provider to tell it that some elements of your link infrastructure are hosted elsewhere. Then create a hosted voicemail policy. There is a default policy that you can use if you want to. You just have to remember to grant it to the users you want. Now notice this bullet right here. This is super important. Enabling users for hosted voicemail doesn't have anything to do with enabling them, right? So if I take the people over here in Sunnyvale and I say, oh, I'm going to enable you for hosted voicemail, and you're not enabled at all, it does nothing. This just controls the link side of this, or the hybridizing side of this controls where the call for a enabled user goes. If you're not enabled, it doesn't matter because you won't have voicemail. Then this last step, setting up hosted contacts, read the documentation. It explains why you do that and how you do it better than I can in the amount of time that I've left myself. Basically, though, this is just a way that the PBX needs to know where, or link, needs to know where to send calls that should be answered by an automated attendant running on your hybrid Exchange environment. Well, you don't have to. That's a good question. Do you provide OVA for your hosted users? If you want to, you can, but you don't have to. And many customers don't because they just want call answering, right? They don't actually want to replace their existing live attendant or automated attendant. Because, very brief digression into telephony weirdness, there are dedicated boxes that just do automated attendant stuff that you can buy, just like there are dedicated voicemail boxes. So you might have a PBX from vendor A, and a voicemail box from vendor B, and an automated attendant box from vendor C. You can replace all of those with Link plus Exchange, or you can replace one of them, or two of them, or none of them. Right? I mean, you can deploy Link and Exchange in parallel with your existing phone system and just move users over. Right? But I'm glad you said that after I switched the slides, the subliminal advertising message stayed up a little longer than I intended it to. I like Tony's book better than mine. It's thicker, for one thing. It's an excellent book, and I recommend it without any joking at all. I will be happy to stick around and answer your questions. I want to thank you for your patience, because I know I ran long. But if you have questions, you're welcome to stay, and I'll be happy to answer them. Fill out your evaluations, eat your vegetables. If you have the opportunity to call your parents, you should. You know, they love you. They probably would like to hear from you. Drive safely. Take your vitamins. Y'all know where I'm going with this. Thank you.